Hello, welcome back to Uncle Sal's Garage. If you remember on the last episode, it was all about the pistons. We gapped and clocked them, we measured the deck height, and we calculated the compression ratio. On today's episode, we're going to use shims and measure the actual deck height with the pistons installed on the motor, and we're going to work on our Valvetrain geometry. Let's get started.
Step 1. Measuring the deck height with the cylinders and shims installed in the motor.
So I don't have any tools that are specifically designed to measure the deck height. So what I've been doing is kind of hacking it together. I've got a T-square that I was able to repurpose for this. The threads of my articulated arm fit perfectly in there. And so what I've been doing is coming over here to the vise, zeroing it out. Then we come over here to the motor and I kind of bring it as close to the center of it as possible, and I read the deck heights. And here's the deal. I went and ordered 150 shims. They're huge, and they give me a deck height of 0.068. I get 6.8, and that's an 8.8 compression. And through various posts on 914 World and my own research, I think I'm looking at a target of 0.045. That's what I want. That's what I'm hunting for proper quench. I'm in shim hell, and I went and bought a whole bunch of shims. Okay, let me talk you through where I'm at. I just put the 90 and the 60 base shim on the motor, on cylinders 1 and 2, and I went and took a whole bunch of measurements. So on cylinder 1, I got 49, 49, 48, and 49 thousandths under. And then I cycled the motor. I kind of spun it a couple times around, and I re-zeroed my dial bore indicator, and I got 49, 49, 48, and 48, 49-ish. So cylinder number 1 was really great and really even between the two measurements. Cylinder number 2 was a different story. That's the one I just got done measuring. I did, same deal. The initial measurement was 49, 48, 48, and 50. And then I, cycled the motor and I re-zeroed my dial indicator, and I got 46, 45, 44, 45, which is way, way, way different. So I guess the cycling of the motors really helps kind of like level out the piston. But just to give you a sense, I take it sort of from this side, and then I kind of rotate 90 degrees, and I take it from here, I rotate, and I do that 2 more times, and that's how I get the 4 measurements. I should also mention, each time I'm doing this, and this is literally impossible to do while holding the camera because I have to move the flywheel, but every time I do this, I find top dead center with the flywheel by just watching the number, hit its lowest point, and that's how you know it's top dead center. So I am going to call this done. I'm hunting for 45, and I'm not going to get it with the shim assortment that I have, but I'm going to get close in the sense that I'll be under 50.
Step 2. Assembling the rocker arms with solid spacers.
But what I'm doing here is I'm simply trying to stack the right number of shims so that my lifter kind of comes down, a little bit, not directly, but a little bit off of directly. I've been told because you want the valve to spin, so you want that motion to kind of spin it, but you don't want it to be super off to the side, right? So you want to get it sort of center, but a little bit off is what I've been told. And I think this is actually, kind of doing it. And well, I just moved it with my hand, and it's not tightened down, but this is what it would look like. And I think that looks decent. I might play with a different sort of amalgamation of these shims, but I don't have that many of them, so I kind of have to use one from each bucket for each sort of time I'm setting these. So I'm gonna see if I have enough to do multiple of certain ones to get it exactly on center. But I'm going to continue stacking this rocker arm with the other rocker, the solid spacer, and some other shims. So I'll come back to kind of tell you guys where I landed. So I kind of like where these are sitting relative to the valve stem. I should also mention that I of course, have the 4/1000ths feeler gauge. I had put that in there, squeeze them tight, tighten these guys down, then release the feeler gauge. So this is sort of correct in terms of the lateral play. Even though, you know, they don't fall on their own, I would have thought that they'd be a little more like loose. But they're not binding or anything, but they're definitely, there's a little bit of resistance. So I'm not sure if that's like the correct way it should feel, but I mean, that's the spec. I used the 4/1000ths, squeezed them, tightened them, removed it. So this is going to go on the motor now. Let's see what's up.
Step 3. Making an adjustable push rod to play with the Valvetrain geometry.
I just cut one of the stock push rods, the old ones, with the archery cutter that I bought. Man, that's a lot thicker than I thought it would be. I'm impressed. So what I'm doing is tapping it, and I'm going to cut the end off of this. I'm just going to sink this threaded stud basically into the push rod on both ends, with maybe 1 or 2 nuts to prevent it from walking on me. And I'll have myself an adjustable push rod. So yeah, just working through the tapping process now. I just got done trimming the length of the stud here with my Dremel and my vise, and I'm going to put the other end of the push rod that I tapped yesterday in here, so it sinks about that deep. I'm going to put it in there with a couple nuts to lock it off, and that'll be my adjustable push rod. Well, I'm about at wit's end here. This is the second adjustable push rod that broke. This one bent, so I stopped using it. And I decided to use the stock push rods because they're beefier. And I drilled and tapped them, and you know, they're not doing well. This is broken, so I really don't know. So I made yet another push rod. This one I put the tip from this adjustable one I bought in the store that got bent. And obviously this is the one I tried to make before that got bent, so 2 bent. I got this one here, and I just set it to 272 millimeters, and I'm about to get my dial bore indicator in here and test the lip.
Step 4. Achieving proper valve lift as indicated on my cam card. So let me explain what I'm doing here. It's very tedious. First, I'm taking an adjustable push rod and setting it to a particular length. For instance, 272 millimeters. Then I'm installing the rocker assembly onto the head. Then I'm setting my dial indicator to the lip of the valve retainer and zeroing it out. Last, I'm cycling the engine through its full rotation, looking for how much lift I achieve, as indicated by my dial indicator. Since my cam calls for different lift values for intake and exhaust, I need to do this 2 separate times. All in all, this took a ton of fiddling and several weeks of me playing with this in my spare time.
This is pretty cool. So at full lift, I've got 0.476 with a 272 millimeter push rod tube, and I'm looking for 0.494, and I have 0.476. So I think if I extended my push rod a little beyond 272 millimeters, I would get there. So let's see if we can do that now. I just set my adjustable push rod to 272.52 millimeters, and I got a lift of 478.5 from the exhaust on cylinder number 1. And I'm shooting for 494, so that's well within the 5% range. So what I've done is I've set the rotation to half lift, so half of the lift I'm getting, which was 478, is 239. And I'm looking for the valve adjuster stem to be pretty much in line with the valve, and that looks pretty good to me. It's a little to the left, I think, of the center line of the valve, but I can't really go any bigger with the push rod because my swivel foot kind of gets caught up in the rocker arm. I didn't cut relief pockets, so I'm inclined to call this done for exhaust pushrod length, given how it looks at half lift, and then I'll show you right now what it looks like at full lift. And here we are at full lift. We've got 478.5, and my valve adjuster stem is now a little to the right of the center line of the valve. So it pretty much will strike it on, a little to the right of the valve, and then as it releases, it should lap it in that direction, which would presumably cause it to spin clockwise. So I think this is correct. If anyone has any other ideas, please let me know. All right, I tried 272.75, and that's pretty much at the mechanical limit of our rocker arm. The swivel foot is going to go too deep into the cup, and I don't have a relief pocket cut for it. So this is as long as I can make my push rod. And then this is the geometry at half lift. So I've achieved a 460 lift, and this is here at 230. And it's not exactly straight in line with the valve stem, but I think it's close. And I will show you here what it looks like at full lift in just a sec. It keeps bouncing between 459 and 460, but it's basically 460 lift. This is fully open on intake. Not quite getting the 507 I'm looking for, but the geometry at full lift here goes a little bit past the valve stem. This is how high as I can go. I can't get any higher values without changing, sort of drilling out the cup here, creating more relief pocket, extending the push rod more, and then seating the swivel foot deeper into the rocker arm. And I really don't want to do that. So I'm going to live with 460. It's about 90% of the lift I'm looking for in intake. I like the geometry-ish, and I think I'm just going to run with that.
Next up on Uncle Sal's Garage, now that we have our valve chain geometry squared away, we're going to be assembling the long block.